Hello and welcome to a video tutorial on duration calculation. Here we have two different bonds. This is coming from page 89 in Fabozzi. It says calculate the requested measures for bonds A and B. We're not going to actually do those, all of those, but we are going to do maculae and modified duration. So you should just take a peek at that problem. It's paid semi-annually. That's the important part that's not written here. So bond A, the coupon is 8%, yield to maturity is 8%, years is 2, it's semi-annual, which shouldn't surprise you that if the face value is 100, it's priced at par because these two are equal. So we do the different periods, and since they're semi-annual, there are 4 periods, and the cash flow is 4, 4, 4, and 104. And we present value those cash flows using the simple present value equation where we have to remember we are dividing the annual yield to maturity by 2. So that gives us 100, and then to calculate this kind of quick way of doing duration, we look at the periods times, or the period times that present value of the cash flow. These calculations can also be seen in tables 4, 5, and 4, 6 of your book. That's on page 65 and 66. So we have T times the present value of the cash flow, and then another summation of all those down there. And then here you have 1 over 1 plus the yield to maturity divided by 2 raised to the period plus 2 power. And then here you have the year times the year plus 1 times the cash flow for that year. And here all we're doing is putting these two equations, one over the other. It's just combining these two equations to get that equation where it's the year for the period times the period plus 1 times the cash flow for that period divided by 1 plus the annual yield, which in our case is divided by 2 times T plus 2, and then the summation for these two. So an interesting thing here is how to insert a formula. If you there are instructions right here. You go to anywhere and you say insert object, and you can pick Microsoft equation, and you can make this anything you want. So we could do equals a plus b x, and then squared. You could go and put this like that, so it gives it to you there, but that's how we created these equations. So now we're going to look at the different ways to measure this. The Macaulay duration in half years is 3.78, and you get that simply by dividing the T times the present value of the cash flow divided by the present value of the cash flow, the sum of those. Okay, so 377 divided by 100 gives you 3.78. So that's in half years because this is a semi-annual bond, and we had these 4 periods. But you might think that to get the duration for years you multiply by 2. That's false. You see this note here. It says remember to divide by 2 to convert duration to a yearly figure, not multiply by 2 like you do with yields. So here we have the Macaulay duration for this semi-annual periods divided by 2 gives you the Macaulay duration for the entire year, or in years. So modified duration, here's the equation that the modified duration equals Macaulay duration divided by 1 plus y, or Macaulay duration times 1 over 1 plus y, and remember y we're dividing by 2, and that one you don't have, this one is already converted because we're using a converted Macaulay duration figure. So you don't have to multiply this, but you don't have to divide this by 2. So the second derivative, this is just what we did here. The sum of all that is the second derivative, and the only reason you use that is to convert or to get the convexity. So for convexity, you do the second derivative divided by the present value of all the cash flows. And again, convexity in years, in this case, you have to do 2 to the second power. So if this is what we know, divide by 2, but because it's a second derivative, you have to do that to the second power. And now here is the quick and easy way to do it in Excel. For Excel duration, which is Macaulay duration, or Macaulay duration, you say duration, which is a formula in Excel, and it asks you for the settlement date. Here we're using the simple date function, so January 1st, 2000, and it matures January 1st, 2002, so it's a 2-year bond. The annual coupon we have, which is 8%, and the annual yield to maturity, which is 8%, and the frequency is twice a year, so that gives you that simply. Same thing for modified duration, or M duration, parentheses, settlement date, parentheses, maturity, coupon, yield, and frequency. So note Excel formulas, we did that, and then we see that this bond has a modified duration of 1.81. If we look at a bond that's has a larger coupon and fewer yields, or more years to maturity, it's not priced at par, and we look, it has a higher modified duration, which should make sense to you. So I think that is quickly everything on the 2 different forms of duration, or the 2 different measures of duration in Excel, modified duration and Macaulay duration.